We look up at the night sky. We see stars. We see the moon. We do not see the thin, invisible shell of human activity surrounding our planet. It is a cloud of metal, plastic, and frozen coolant, moving at incredible speeds. A tiny fleck of paint can hit with the force of a bowling ball. Most of us never think about it, yet it holds a quiet, growing danger. The technology that connects our world could become the source of its own undoing. One failure, one small impact, can start a chain reaction, with consequences that reach every corner of the globe. Here's the roadmap. We'll set the baseline, follow the first hits, track the system's reaction, watch escalation, and see the altered state. Then the deeper reason it happens. And we will ground every step in the mechanisms experts already see. To understand what happens when things go wrong, we start with how crowded space has become. The stakes are rising because the system is already under pressure. Low Earth orbit is not empty space. It is a resource, now crowded. Thousands of operational satellites run GPS, weather, and connectivity. They guide our cars, forecast storms, and link remote communities. By early 2025, over 11,800 active satellites, on track for a six-fold increase by 2030. The same real estate is also a junkyard. Defunct craft, empty stages, and countless fragments from past breakups. Agencies track tens of thousands, but most pieces are too small to see. ESA estimates over 39,000 cataloged, about 1.2 million 1 to 10 centimeters, and roughly 130 million between 1 millimeter and 1 centimeter. Models show debris would still grow even if launches stopped. At popular altitudes, active satellite density now matches debris in places. Collisions can be satellite vs. satellite as easily as satellite vs. debris. In early 2025, one constellation logged avoidance actions every few minutes. The stage is set. The actors are in place. Only a trigger is missing. Imagine a Tuesday morning, 800 kilometers above the Pacific. A dead satellite and a drifting upper stage. Neither can maneuver. Closing speed, nearly 15 kilometers per second. The result is not a bump. It is a hypervelocity explosion. Several tons of hardware vaporize and shatter in milliseconds. Thousands of new fragments, some like panels, many like coffee cups, millions smaller than a fingernail. The blast flings debris across a wide range of new orbits. Some go higher and linger, some decay. Many stay in the crowded band. This has precedent. In 2009, Iridium and Cosmos collided, creating nearly 2,000 trackable pieces. In August 2024, a Long March 6A rocket body fragmented. Hundreds of new objects added. Events like these drive measurable spikes in catalog debris. Sensors catch the big pieces. The small ones remain invisible. In an instant, the local sky becomes more dangerous. One collision has changed the operating environment for everyone. The cloud spreads like a stain, encircling the planet within hours. Inside it, collision probability rises sharply. A communications satellite is struck. Arrays shredded. The bus punctured. Silence. A science payload loses its primary instrument. The mission is over. Over the first 2 days, anomalies mount. Some crafts go dark. Debris hits debris, spawning another smaller cloud. One collision increases the odds of the next. The cascade begins. On Earth, outages appear. Minor, then frequent. Most people don't know why, only that trust is slipping. The sky is now seeded with the instruments of its own destruction, and the system is about to react under strain. When reactions pile up, unintended consequences follow. If this breakdown helps you see the hidden mechanisms, tap like, drop your thoughts on prevention strategies, and subscribe for more what-if systems failures. Your ideas shape the next scenario. The first impacts give way to a new phase: our reactions. Fleets execute unprecedented numbers of avoidance maneuvers. We already saw warnings every few minutes across a single network. Each burn consumes fuel and shortens lifespan. With many craft maneuvering, prediction becomes unreliable. One company's dodge can raise another's risk. Trust phrase. Insurers face a flood of claims. Premiums surge. Some orbits become uninsurable. Launch plans pause. Investment cools. Expansion stalls. Add a major solar storm, and avoidance can halt for days. Without dodging, collision odds jump, accelerating the cascade. Multiple stresses converge, pushing the system past its limits. Avoidance increases uncertainty, which triggers more avoidance. Tracking data gets fuzzier. Operators grow more conservative. More fuel spent. More path changes. More uncertainty. Secondary impacts now generate multiple lethal microclouds. The event rate climbs from rare spikes to a steady drumbeat. ESA simulations warned some bands already trend upward on their own. Tracking networks saturate, designed for steady state, not exponential growth. With stale catalogs, avoidance devolves into guesswork. Some craft are parked in safe mode, hoping to ride it out. The runaway cascade becomes real. The process feeds on itself. Not one great blast, slow attrition that turns highways into minefields. Months to years later, the cascade slows, not from safety, but from scarcity of large targets. Valuable corridors, including sun-synchronous lanes, become effectively unusable. Launching through them is a gamble few can take. Shielding and insurance costs become astronomical. Daily life feels it. Less connected, less reliable. High-precision positioning weakens. Shipping, aviation, and farming all feel the drift. Low-latency satellite internet is crippled. Replacements are too risky. A divide that was shrinking widens again. Long records of climate, ice, and forests are broken. We are partially blind to Earth. Space telescopes in LEO end early or never begin. Human spaceflight becomes risk-loaded. Even stations grow isolated. Deep space missions burn more fuel to thread safe corridors. Not an apocalypse, just a world less connected, less informed, less capable. A vital shared resource squandered, a monument to the cost of neglect. We followed one failure through debris, outages, maneuvers, chaos, cascade, and a degraded future. The flaw wasn't one satellite, it was system density crossing a threshold. At that point, failures propagate, amplify, and cascade. Weak links weren't only technical, they were economic and political. We could launch at scale faster than we could govern at scale. The future is not written. This is a warning, not a prediction. We can remove high-risk objects. We can harden design and enforce disposal. We can share data and coordinate maneuvers. Difficult, expensive, global, yet possible. Collisions reflect thousands of choices over decades. Better choices bend the curve. Our orbits can become a testament to foresight, not neglect. Which hidden loop should we test next? If you value grounded, mechanism-first what-ifs, hit like, share your take in the comments, and subscribe. Your ideas drive future investigations. What scenario should we explore next? Share your ideas below. You've been watching If Verse, where imagination meets possibility. See you in our next reality.